Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Engku Mohammad Shah Hakimi bin Engku Bunia, and today I would like to present to Puan Rashida and Dr. Nur Ain for my Wildfire surveillance system for PEAT soil area. This task is required for me to fulfill my final year project, and I have finished the prototype for the Wildfire surveillance system for PEAT soil area. Okay, we'll proceed for today's content. So this is the presentation outline. First of all, there is 5 presentation outline. So first of all is the introduction. In the introduction, I will explain about the background, problem statement, aim, scope, objective of the study. And then we'll proceed to the literature review. Literature review is based on the research that have been made during the PSM1. The literature review based on the related project. So the third one is methodology. So in the methodology, I have split the outline for 2, which is the software development and hardware development. And the fourth one is result and discussion. In result and discussion, we will see the finished product, simulation, and I will attach also the testing for the Wildfire surveillance system project. And then the fifth one is conclusion. The conclusion is for overall summary of the project throughout the year.
Okay, so for the introduction of Wi-Fi surveillance system, there is a few guidelines that have been made for the research. First of all, it is the causes of Wi-Fi. There is 5 causes of Wi-Fi. First of all, the high temperature and low humidity. And then the second one is strong winds and low precipitation and droughts. And the fourth one is high loads due to dry grass, brush, and dead trees in the peat soil area. And then the last one is human-made or natural ignition sources such as power lines, fireworks, or lightning strikes. And then the peatland characteristics. Peatland is a unique forest because it has the accumulation of dead plant material due to its heavy canopy, and then it has limited natural fire breaks such as river, and due to high temperature, peatland usually located in high temperature location, and it also have strong winds. And then have dry and dense vegetation at bottom of the forest, and it containing the high fuel load due to the accumulation of dead plant.
And then we will proceed to the problem statement. For the problem statement, there is 3 problem statement right here. For this project, which is the wildfire have become increasingly common and have caused significant damage to natural resources and human life. The second one is early detection and response is crucial in controlling and extinguishing small fires before they grow into larger and harder to control wildfires. And then the third one is the traditional wildfire method, such as ground patrols and lookout towers, are not sufficient and may not provide adequate coverage in remote and rugged areas. So I have also attached the news from the California second largest wildfire, which caused by the spark from the transmission line. So this is not a simple problem in the world, but it is a significant problem for us to take a further action before it will have a damage to the natural resources and human lives. And then for the objective. There is 3 objectives that have been set for this project. First of all, the aim of the study is to develop wildfire surveillance system for the peat soil area. The first one is to develop wildfire detection system for peat soil forest area. The second one, to verify the performance of the proposed system in a real situation via experimental setup. For the second objective, a result of the efficiency for solar panel have been taken for 7 days, and it has been attached in the report. And then for the third one, to investigate the real-time data of smoke and temperature of the peat soil as a preventative measure from wildfire. For the project scopes, there is 4 project scopes that have been set to achieve the objective, which is the integration with existing resources. Second one is research and development for the wildfire surveillance system. And the third one is the implementation of installation of the wiring and all of the technology that have been researched. And the fourth one is design and testing all of the project. Okay, then we'll proceed for the literature review. There is 5 research that have been made as a guideline for this project. First of all, the IoT-based environmental monitoring system for Brunei peat swamp forest, IoT-based intelligence for fire emergency response system. The third one is design a home fire detection system using Arduino and SMS gateway. The fourth one is IoT-based forest fire detection system. And the fifth one is wireless sensor network for wildfire detection and notification via walkie-talkie network. And based on all of this literature review, a conclusion can be made. The disadvantages and advantages have been written in this table. And in my opinion, all of this research is based only on the monitoring of wildfire only. So we need to implement a fire extinguisher system as a first barrier, as a first step to put out the fire before the authorities can come. Okay, so for the methodology, this is a system block diagram for the wildfire surveillance system. There is 5 sensors that I have mentioned before, and the ESP8266 is powered by the solar panel. The ESP8266 also will transfer all of the data collected by using the GSM SIMS 900A, and it will be transferred to the Blynk server. And the microcontroller also, the user also can control the water pump and the pilot lamp as in a manual mode, and the servo motor is used to aim the fire extinguisher towards the fire. This is the system flowchart for the project. So this is a flowchart started with start of the program, and then the ESP is on standby mode. The MQ2, the HD22, flame sensor, and GPS will always sending data to the ESP8266 to be interpreted. And if all of the sensor is, or one of the sensor is triggered more than the data that have been set, thus it will trigger the pilot lamp, which will notify the people nearby, and then the data will be sent to the Blynk server. And then the Blynk server, the user also can put out the fire as a first step by using the Blynk app and turn on the water pump. And if the fire is extinguished, and then the project or the program will start from init standby mode. So for the result and discussion, so this is the circuit design that have been followed in this project. At the left, we can see the 3D layout design for the prototype. The 3D layout design using the SolidWorks application software. And then the second one is positioning of the prototype by using the SketchUp. And then this is the final prototype, the prototype of Wildfire surveillance system. The introduction, I will introduce for the features, technology used, and the sensors used for the Wildfire surveillance system. For the features, there is 4 features in the Wildfire surveillance system. First of all, the monitor pit soil environment. We are using 3 sensors to constantly monitoring the pit soil area to prevent the wildfire from happen. I will explain after this about the sensors. And then there is a wildfire alert. Wildfire alert is a features that powered by the 12-volt battery, and it is controlled by the relay, and it will alarm the nearby people, if there is nearby people, by using the pilot lamp, which containing the buzzer. And then there is also IoT application, which currently we are using the Blynk interface. And that one more additional features in the Wi-Fi surveillance system is small fire extinguisher, which powered by the motorized water pump, 12-volt motorized water pump. So the reason why the small fire extinguisher is attached in the monitoring system is because before the authorities can come and put out the fire. The project is the first stages of the first stages which can put out the fire. And then the technology used, for the technology used, we are currently using the ESP8266 microcontroller. The reason is because the ESP8266 is cost effective, and it is much more powerful rather than the Arduino Uno. And then the connectivity is we are using the 2G technology, which is by using the GSM SIM 900A, which the data will be transferred from the monitor system to the Blynk server. And the user can see it or see the data from the IoT interface. And then for the sensors, we are using 5 sensors. First of all, GPS Neo 6 module. So this module is used to gain the longitude and latitude of the Wi-Fi surveillance system. So when the Wi-Fi happen, we can know the exact longitude and latitude of the project. And then for the small fire, we are using the infrared sensor. Infrared sensor is used to detect the flame, and it is using the infrared technology from 3 feet length. And then we are using MQ2, which to detect the smoke, MQ2 detect which detect the carbon monoxide concentration. But we need to note that the MQ2 need to be heat up before we are using the prototype. And then for the humidity and temperature, which humidity and temperature, we are using the DHT22. For your information, DHT22 is much more precise and powerful in datasheet rather than the DHT11, the older version. This is the new version of DHT sensor. Okay, so this is the data collect for the Wi-Fi surveillance system power integration, which is by using the solar panel, 18-volt, 10-watt solar panel. Based on the data collected, it can be concluded that the solar panel is more than enough to power up the system, since the system are currently using low power consumption, which is less than
less than 8 ampere, 8 milliampere for the sensor for an hour. And based on the calculation that has been shown, the battery can support the system without any charge for more than 8 hours, 8.75 hours. So if a few improvement for the pole extend higher, and a much more powerful battery and solar panel is attached to the system, I think the project or prototype is suitable to be located at strategic places, especially in peat soil area, to monitor the wildfire.
Okay, we have come to our final.
And then for the sensors, a few testing have been made. After 5 testing, the accuracy of all of the digital sensor have been tested. It is by changing the distance between sensor and turn detection. We have made 5 tests, and the output have been seen by using the serial monitor in Arduino IDE. So it can be concluded that the accuracy of the sensor can detect fire from 3 feet height.
Content, which is the conclusion. As a conclusion, the aim of the study is to develop a wildfire surveillance system for peat soil areas. The system aims to provide an efficient and cost-effective solution for early detection and monitoring of potential wildfire threats in these areas. The use of the ESP8266 microcontroller in the system can provide a reliable and low-cost option for remote and rugged environments. And then the system objective is to detect small fires at an early stage, process sensor data, and trigger the fire extinguishing mechanism and transmit the data. Thus, the authorities can know that there is a potential wildfire that will be happening at the area. And then the regular monitoring and maintenance of the system are crucial to ensure its reliability, effectiveness over time. This wildfire system can play an essential role in protecting human life and natural resources from wildfire damage in peat soil area. It can provide early detection, efficient response, and reliable monitoring of wildfire threats in peat soil area. I think that's all from me, and thank you very much.